Hello, my name is Jason Farmer, and my research project was the development of a low-cost, remotely operated underwater vehicle, or ROV. As underwater industries continue to grow, ROVs are needed for exploration, surveillance, and various other tasks that are too dangerous or impossible for humans to do. The recreational scuba diving limits are around 130 feet, and highly skilled divers with the right equipment can go deeper, but some underwater tasks are just too deep for humans. In general, humans are simply not great at working underwater. The recent production of reliable and low-cost underwater components allows the development of a new generation of ROVs to accomplish these tasks. This project required me to research many different topics, so the poster has 6 sections that summarize different parts of the ROV. First is the housing, or sometimes called the hull. The goal is to keep the housing as small as possible in order to have a good depth rating without using too much material. A smaller housing means less surface area, and less surface area means less force on the housing at any given depth. If you increase the size of the housing, then the walls have to be thicker to achieve the same depth rating, and the price goes up. Second is the sensors on board the ROV. There is a camera for recording video and streaming it to the operator on the surface, a temperature sensor to measure the temperature of the water, and a pressure sensor for determining the depth of the ROV. There is also an IMU, or inertial measurement unit, to get orientation and acceleration data for stabilizing the ROV. And lastly, a leak sensor is inside the housing to make sure that it's watertight at all times. The ROV gets power from a lithium-ion battery pack, and its specifications are on the poster. The battery allowed me to avoid using a costly power supply and large power tether. Unfortunately, a tether is still necessary for data communication, but it is much smaller and less of a hassle than a power tether. It would be nice if the ROV could be completely wireless, but underwater wireless communication is primarily done with acoustics because electromagnetic communication generally doesn't work underwater, and the data rate of acoustic communication is way too slow for video. The ROV is controlled by a Pixhawk flight controller that runs a software called ArchiSub. It drives the thrusters and uses data from the IMU to stabilize the ROV. The other computer on board is the NVIDIA Jetson Xavier NX. This computer is very good at running neural networks, and it will be used in the future for more research involving artificial intelligence. The last section is the thrusters and light. As seen in the pictures, the ROV has 2 large horizontal thrusters and 4 smaller vertical thrusters that move the vehicle and stabilize it. There is also a light attached right above the camera viewport to increase the visibility in dark water. Thank you for listening to my presentation, and please let me know if you have any questions.